June 13th, 1944. 4:18 a.m. The darkness over southern England was broken by a sound no one had heard before. A harsh, mechanical buzzing, like an enormous motorcycle in the sky, growing louder as it approached the Kent coast. Royal Observer Corps spotters at Dymchurch strained their eyes toward the channel, searching for the source of this strange new noise. What they saw defied immediate comprehension. A small aircraft flying straight and level at about 2,000 feet, trailing a bright plume of flame from its tail. No navigation lights, no deviation in course, just that terrible buzzing and the glowing exhaust painting a line of fire across the pre-dawn sky. The spotters reached for their telephones, uncertain what to report. Was it a German aircraft on fire? A new type of bomber? Whatever it was heading inland at tremendous speed, that mechanical pulse growing louder, then suddenly, horribly, stopping. In the silence that followed, experienced observers knew what was coming. 4 miles inland from Dymchurch, in the small village of Swanscombe, the silence ended in thunder. The explosion destroyed a railway bridge, killed 6 people, and announced the arrival of Hitler's first vengeance weapon. The V-1 flying bomb, Germany called it Vergeltungswaffe 1, Retaliation Weapon 1, had reached London. What followed would be an 80-day campaign of terror that would kill nearly 6,000 people, destroy 30,000 buildings, and force the British to deploy the most sophisticated air defence system ever created. This is the story of the weapon that brought the sound of buzzing death to London and the desperate race to stop it. The V-1's origins lay in desperation wrapped in technological innovation. By 1942, Germany was losing the strategic bombing campaign. British and American bombers were systematically destroying German cities while the Luftwaffe, once the terror of Europe, was being ground down by attrition. Conventional bombing raids against England were suicide missions by 1943. German bombers that had once roamed freely over British skies were now shot down in droves by RAF night fighters equipped with radar and experienced pilots. At Peenemünde, on Germany's Baltic coast, a team of engineers led by Robert Lusser was developing something revolutionary. Not a piloted aircraft, but a flying bomb. An unmanned cruise missile powered by a pulse jet engine, guided by a simple autopilot and cheap enough to build by the thousands. The concept was brilliantly simple and terrifyingly efficient. Why risk trained pilots when you could send an expendable robot loaded with explosives? The pulse jet engine was the key innovation. Designed by Paul Schmidt, it was perhaps the simplest jet engine ever conceived. A tube open at both ends with a series of spring-loaded shutters at the front and a fuel injection system. As air rushed into the front, fuel was sprayed and ignited. The explosion slammed the shutters closed and blasted exhaust out the rear, creating thrust. The shutters reopened due to spring pressure and the partial vacuum created by the exhaust, allowing fresh air to enter, and the cycle repeated, 50 times per second. That's what created the distinctive buzzing sound that would terrify London. The mechanical pulse of controlled explosions happening faster than the human ear could distinguish individual detonations. The engine was crude, inefficient, and produced a specific fuel consumption rate that would make modern engineers weep. But it required no turbine blades, no complex compressors, no precision machining. It could be stamped out of sheet metal by semi-skilled workers in factories that had never built aircraft engines. Each pulse jet cost roughly 600 Reichsmarks to produce, about what Germany spent on 200 artillery shells. The entire V-1, including warhead, airframe, engine, and guidance system, cost less than building a single conventional bomber. The airframe was equally simple, a tubular fuselage made of welded sheet steel, stubby wings constructed from plywood, and a distinctive cruciform tail. No landing gear, the V-1 would be launched from a ramp and simply crash when it ran out of fuel. No complex systems, no radio, no defensive armament, just fuel tanks, a warhead, and enough guidance equipment to point it in the right direction. The guidance system was ingeniously simple. A magnetic compass set the initial heading, a gyroscope kept the wings level. An airspeed sensor drove a small propeller in the nose, which turned a mechanical counter. When the counter reached a preset number corresponding to the distance to target, it triggered 2 mechanisms. Small explosive bolts locked the elevator in a nose-down position, and spoilers popped up on the tail, ensuring the V1 would dive into the ground. The entire guidance system could be assembled by workers with minimal training using off-the-shelf components. Testing began in December 1942. The first launches were spectacular failures. V1s tumbled off their launch ramps, exploded in mid-air, or flew in random directions. The pulse jet proved temperamental, refusing to start or cutting out unexpectedly. The autopilot malfunctioned. The airframe vibrated itself apart. Engineers at Peenemünde worked frantically to solve each problem, knowing that Hitler was demanding results. By October 1943, the V1 was reliable enough for mass production. The specifications were modest, but sufficient. Maximum speed, 400 miles per hour. Range, 150 miles. Warhead, 1,370 pounds of Amatol high explosive. Accuracy, well, that was the problem. The simple guidance system could get the V1 to within about 5 miles of its target under ideal conditions. With wind, mechanical variations, and the crude autopilot, the actual accuracy was closer to 10 miles radius. Against a military target, this would be useless. Against London, a city of 8 million people sprawling across 700 square miles, you'd hit something. Hitler saw the V1 as the weapon that would break British morale and force them out of the war. In his deluded strategic vision, thousands of flying bombs would rain down on London daily, creating such terror and destruction that the British government would sue for peace. He was particularly pleased that the weapon required no pilots, as the Luftwaffe was running desperately short of trained aircrew. The V1 could be built by slave labour in underground factories beyond the reach of Allied bombers, launched by simple crews with minimal training, and delivered death to London without risking a single German pilot. Production was assigned to the Volkswagen factory at Fallersleben, which had been converted from automobile manufacturing to weapons production. The underground Mittelwerk facility in the Harz Mountains, built by concentration camp prisoners, would produce components. Assembly would be handled by forced labourers from across occupied Europe, working under brutal conditions to meet impossible quotas. By early 1944, production was reaching 1,000 V1s per month and accelerating. The launch sites were another German innovation. Instead of requiring airfields with their vulnerable runways and support facilities, the V1 would be launched from simple steel ramps using a Walter HWK-109 steam catapult. Hydrogen peroxide and potassium permanganate mixed in a combustion chamber, creating superheated steam that drove a piston down a cylinder. The piston pulled a launch trolley carrying the V1 up a 50-metre-long ramp, accelerating it to 250 miles per hour in less than 2 seconds. The G-forces would have killed a pilot, but the V1 didn't care. The launch sites, called ski sites by Allied intelligence because of their distinctive shape when photographed from above, were built across northern France. Each site consisted of the launch ramp, several curved buildings for storing V1s and preparing them for launch, and minimal facilities for the launch crews. The entire installation could be constructed in weeks, using local labour and prefabricated components. By June 1944, over 100 sites were operational or near completion, positioned to aim their lethal cargo at London. British intelligence had been tracking the V1 programme since 1943. Photo reconnaissance flights over Peenemünde had captured images of small cruciform aircraft on launch ramps. The curved buildings appearing across northern France were obviously connected to some new weapon system. But the British didn't fully understand what they were seeing. Some analysts thought it was a new type of anti-aircraft rocket. Others suggested it might be a pilotless aircraft, but the concept seemed too futuristic. Intelligence reports from the French resistance described mysterious flying bombs being tested, but these reports were fragmentary and difficult to verify. The British response was called Operation Crossbow, a massive bombing campaign targeting V1 production facilities, storage sites, and launch ramps. Rough, heavy bombers struck Peenemünde in August 1943, killing hundreds of German engineers and workers, but failing to stop the program. American B-17s and B-24s pounded the suspected launch sites across France through late 1943 and spring 1944. British fighter bombers attacked anything that looked like a ski site. It was a race against time, with Allied bombers trying to destroy the launch capability before it became operational. But you can't bomb simple steel ramps back to the Stone Age. The Germans simply built more sites, rebuilt damaged ones, and developed alternative launching methods using modified ramps that were harder to spot from the air. For every site destroyed, 2 more appeared. By early June 1944, despite months of intensive bombing, the Germans had enough operational sites to begin their campaign. The timing was not coincidental. The Allied invasion of Normandy had begun on June 6, 1944. Hitler was furious at the successful landings and demanded immediate retaliation. Field Marshal Wilhelm Keitel, chief of the German High Command, assured Hitler that the V1 campaign would begin within days. The British would pay for their invasion in blood and fire. At 3:30 a.m. on June 13, 1944, launch crews at sites across the Pas-de-Calais region of France began final preparations. The V1s had been fueled with 150 gallons of low-grade gasoline, armed with their Amatol warheads, and positioned on their launch ramps. The autopilots were set for London, compass headings checked, and distance counters calibrated. At 4:18 a.m., the first salvo launched. 10 V1s roared off their ramps, their pulse jets stuttering to life as they accelerated up the catapult rails and climbed into the darkness. 4 crashed immediately, victims of mechanical failures or autopilot malfunctions. 1 flew north toward the English Channel and was never seen again. 1 turned west and crashed in France. But 4 kept flying, their pulse jets buzzing mechanically as they crossed the Channel at 2,000 feet, heading for London at 350 miles per hour. The first V1 to reach England was the one spotted over Dymchurch. It crossed the coast at 4:18 a.m., flew inland for exactly 4 minutes, then its engine cut out as the distance counter reached its preset limit. In the sudden silence, the V1 tipped nose down and fell. The explosion at Swanscombe destroyed the railway bridge and killed 6 civilians. The age of robot warfare had begun. The second V1 landed at Cuckfield in Sussex at 4:23 a.m., demolishing several houses and killing 4 people. The third reached Bethnal Green in London at 4:25 a.m., destroying a railway bridge and killing 8. The fourth hit Platt in Kent, causing only property damage. By 4:30 a.m., 4 V1s had reached their targets. The kill ratio was terrible by conventional bombing standards, less than 24 casualties from 4 hits. But this was just the beginning. Over the next 24 hours, the Germans launched 244 V1s at London. Only 73 crossed the English coast. Of those, only 13 reached London proper. The rest, crashed due to mechanical failures, were shot down by anti-aircraft fire, or hit by RAF fighters, or simply ran out of fuel and crashed in the countryside. But those 13 V1s that reached London killed 20 people and injured hundreds more. More importantly, they created a new kind of terror. Londoners had endured the Blitz in 1940 and 1941. They understood conventional bombing. You heard the sirens, took shelter, waited for the all clear. The bombs fell more or less randomly, but at least there were pilots above making decisions, following targets, operating according to some comprehensible human logic. The V1 was different. It was a robot, a mindless machine that would crash wherever its fuel ran out, killing whoever happened to be there. There was no logic, no pattern, no way to predict where it would hit. Worse was the sound. That buzzing pulse jet created a noise unlike anything else in warfare. Loud, harsh, mechanical, and somehow more terrifying than the scream of falling bombs because it went on, growing louder as the V1 approached, then suddenly, horribly, cutting out. The silence after the engine stopped was the most terrifying sound in London. Because when the buzzing stopped, you had maybe 10 seconds before the explosion. If you could still hear the engine, you were safe. If the engine cut out and you heard silence, you either ran or prayed, because 870 pounds of high explosive was falling from the sky somewhere very close. Londoners developed a macabre saying, "If you can hear it, it's not for you." The psychological impact was immense. People could cope with danger they could see and understand. But this invisible threat that arrived without warning, that you could hear but not see until the last moment, that killed according to pure chance with no human agency involved, this was something new and deeply unsettling. The British government initially tried to suppress information about the V1, referring to them as pilotless aircraft in official communications. But you can't hide the sound of dozens of flying bombs buzzing over London day and night. Within 48 hours, everyone knew about the new threat. The press, operating under censorship, reported that the enemy is using pilotless aircraft against southern England. Churchill, addressing Parliament on July 6th, was more direct. The enemy has begun to employ against us a new weapon, the flying bomb. It is a pilotless aircraft driven by a jet propulsion motor and carrying a considerable weight of explosive. The British response was unprecedented in scale and sophistication. Air Marshal Roderick Hill was placed in command of air defence of Great Britain, with orders to stop the V1 by any means necessary. What Hill assembled over the following weeks was the most advanced integrated air defence system in history, combining early warning radar, fighter aircraft, anti-aircraft artillery, and barrage balloons in a coordinated defence network. The plan was called the Diver Defence System. Diver being the code name for the V1, the strategy was layered defence. Stop as many V1s as possible over the channel using fighters, destroy survivors over the coast using anti-aircraft guns, use barrage balloons to force any remaining V1s to fly higher where they could be more easily engaged, and finally, position more fighters and guns around London for last-ditch interceptions. The fighter squadrons were the first line of defence. The fastest aircraft available were assigned to V1 patrols, Hawker Tempest fighters with speeds up to 435 miles per hour. Spitfire Mark 14 Thoms powered by Rolls-Royce Griffon engines capable of 440 miles per hour. Even some American P-51 Mustangs joined the hunt. The fighters patrolled designated areas over the Channel and Kent, waiting for radar stations to vector them toward incoming V1s. Intercepting a V1 was more difficult than fighting conventional aircraft. The flying bombs cruised at 350 to 400 miles per hour at low altitude, which was near the maximum speed of most fighters at that height. The pulse jet didn't care about aerodynamics, maintaining constant speed regardless of atmospheric conditions. Pilots had to dive on the V1 from altitude to build up overtaking speed, position themselves behind the target, and opened fire before their speed decayed. The V1 was also remarkably difficult to destroy. It had no pilot to kill, no fuel tanks to ignite, no control surfaces to damage. You had to either destroy the autopilot, rupture the fuel tanks, or detonate the warhead. The small size made it a difficult target, and the vibration from the pulse jet meant it was never flying exactly straight, wobbling constantly in the air. Pilots fired hundreds of rounds trying to hit the small, vibrating target, travelling at nearly the same speed as their fighter. Squadron leader Joseph Berry of 501 Squadron was one of the first pilots to successfully destroy a V1. On June 16th, flying a Tempest, he spotted a V1 over the channel. I dove from 8,000 feet, pushed the throttle through the gate, and barely closed the distance. At 300 yards, I opened fire with my 420mm cannon. I saw strikes on the fuselage, but it kept flying. I fired again, walking the tracers up the body. Suddenly it exploded in a massive fireball. I flew through the debris cloud and the shockwave nearly flipped me inverted. When I landed, my aircraft had over 40 holes from V1 fragments. Some pilots developed alternative tactics. Flight Lieutenant Ken Collier discovered that you could destroy a V1 without firing a shot. If you flew alongside and carefully positioned your wingtip under the V1's wing, then sharply increased your lift, you could tip the flying bomb over. Once inverted, the simple gyroscope in the autopilot couldn't correct, and the V1 would spiral into the ground. This technique, called tipping, required extraordinary skill and nerves of steel. You were flying at 400 miles per hour, mere feet away from a ton of explosives with a malfunctioning autopilot. One mistake and you'd collide. But tipping worked, and several pilots became experts at it. They would fly alongside the V1, match speeds perfectly, slide their wingtip under the V1's wing, then sharply bank. The V1 would roll, the gyroscope would tumble, and the flying bomb would spiral away and crash. Some pilots tipped multiple V1s in a single sortie. Flight Lieutenant Maurice Rose of 501 Squadron destroyed 5 V1s in one day, 4 by gunfire and 1 by tipping. The anti-aircraft defences were the second layer. Initially, anti-aircraft guns were positioned around London in their existing defensive belts, but this proved dangerous. Gunners were firing over populated areas, and what went up had to come down. Shells that missed the V1 fell on London, causing casualties and damage. Worse, fighters and anti-aircraft guns interfered with each other. Pilots trying to shoot down V1s flew into gunfire. Gunners held their fire when fighters were near, allowing V1s to pass through. The solution was radical. Move all the anti-aircraft guns to the coast. Create a gun belt along the coast of Kent and Sussex, where gunners could fire over the sea without endangering civilians. Position fighters on either side of the gun belt, over the channel and inland, keeping them clear of the anti-aircraft fire zone. It required moving 1,500 heavy anti-aircraft guns and 800 light anti-aircraft guns, along with thousands of tons of ammunition, radar equipment, and support facilities. The entire operation took 3 weeks and was completed by late July. The results were immediate and spectacular. With clear firing zones over the sea and improved radar direction, gun crews began destroying V-1s in unprecedented numbers. The introduction of the newly developed SCR-5 and 84 radar from America, which could track fast-moving targets with extraordinary accuracy, transformed anti-aircraft effectiveness. Gunners could now engage V-1s at night and in poor weather with the same accuracy as daylight shooting. The guns themselves were a mix of British and American weapons. 3.7-inch heavy anti-aircraft guns, the workhorses of British air defence, American 90mm guns, and most effective of all, the 40mm Bofors light anti-aircraft guns firing at incredible rates. Proximity fuses, a closely guarded Allied secret developed in America, made anti-aircraft fire exponentially more lethal. Instead of requiring a direct hit, the shells would explode when they passed within lethal radius of a target, detected by a miniature radar set in the shell's nose. The numbers improved dramatically. In the first week of the V-1 campaign, anti-aircraft guns destroyed about 5% of incoming flying bombs. By early August, with the guns repositioned and equipped with proximity fuses, the destruction rate reached 60%. On August 28th, gunners shot down 94 of 97 V-1s that crossed the coast, a destruction rate of 97%. The barrage balloons were the third layer. Over 7,700 balloons were positioned in a belt south of London, floating at altitudes between 2,000 and 5,000 feet, tethered by steel cables. The theory was simple. V-1s flying into the cable belt would either hit a cable and crash, or be forced to fly higher to avoid them, where they would be easier targets for fighters and guns. The balloons were more effective as a psychological weapon than a physical barrier. Only about 280 V-1s were actually destroyed by balloon cables during the entire campaign. But the balloons forced V-1s to fly higher, reducing their accuracy and making them easier to track on radar. Some V-1s flew through the balloon belt without hitting anything. Others hit cables and crashed. The uncertainty added another layer of difficulty to the German targeting problem. The Germans responded to British defensive improvements with technical countermeasures. They modified V-1 guidance systems to make the flying bombs dive immediately after crossing the coast, flying under the guns before the gunners could react. They developed jammers to interfere with British radar. They experimented with launching V-1s from Heinkel bombers over the North Sea beyond the range of the coastal gun belt. The air-launched V-1 campaign began in July 1944. Heinkel 111 bombers would carry a V-1 under their fuselage, fly to within 150 miles of London over the North Sea, and release the flying bomb, which would ignite its pulse jet and fly toward London. This extended the range beyond the reach of most British defences and came at a time when Allied bombing of launch sites in France was making ground launches increasingly difficult. But air launching presented its own problems. The Heinkel crews had to fly straight and level at exact altitude and speed during the launch, making them vulnerable to fighters. Night fighters equipped with radar intercepted the launch aircraft, shooting down dozens of Heinkels. The German crews called it the death flight. Many crews refused to fly V-1 missions after seeing their comrades shot down night after night. By September 1944, Allied advances into France had overrun most of the ground launch sites. The V-1 campaign from France essentially ended on September 1st, when Allied troops captured the last operational sites near Calais. In 3 months, Germany had launched approximately 9,500 V-1s at England. Of these, about 7,500 crossed the English coast. The British defences destroyed roughly 3,500 of those, using fighters, anti-aircraft guns, and balloons. About 2,400 V-1s reached London. Those 2,400 flying bombs killed 5,475 people, seriously injured 16,000 more, and destroyed or damaged over 30,000 buildings. The psychological impact was even greater. Thousands of Londoners evacuated the city. Industrial production dropped as workers spent hours per day in shelters. The constant strain of waiting for the buzzing to stop, knowing that silence meant death was falling somewhere nearby, wore down civilian morale in ways the conventional blitz had not. But the campaign failed in its strategic objectives. It did not force Britain out of the war, It did not stop the Allied advance through France. It did not prevent continued bombing of Germany. The resources devoted to V1 production, thousands of tons of steel, hundreds of thousands of man-hours, entire factories turned over to flying bomb production. These resources could have been used to build conventional fighters and bombers that might have actually affected the war's outcome. The V1 was innovative, frightening, and ultimately ineffective. Its accuracy was too poor to hit military targets. Its warhead was too small to cause strategic damage. Its guidance system was too simple to evade sophisticated defences. Once the British developed effective countermeasures, the V1 became an expensive way to create relatively limited damage. In terms of resources expended versus damage inflicted, the V1 was one of the least efficient weapons of the war. Yet the V1 represented something unprecedented in warfare. It was the first operational cruise missile, the ancestor of weapons that would dominate modern warfare. The concept of an unmanned aircraft carrying explosives to a target, guided by an autopilot, powered by a jet engine, this would become the foundation of military technology for the next 80 years. Every cruise missile, from the American Tomahawk to modern weapon systems, traces its lineage back to the V1. The technical legacy was significant. The pulse jet engine, despite its crude inefficiency, demonstrated that jet propulsion could be simple and cheap. The autopilot system showed that mechanical guidance could work for military applications. The mass production techniques developed for the V1, building complex weapons using semi-skilled labour and standardised components, influenced post-war weapons manufacturing. The Germans themselves learned from the V1's limitations. The V2 ballistic missile, which began hitting London in September 1944, was a far more sophisticated weapon. Travelling at supersonic speeds at altitudes above 50 miles, the V2 could not be intercepted by 1944 technology. But it was also far more expensive and complex, requiring precision components and highly trained launch crews. The V1 and V2 represented two different approaches to unmanned warfare: the cheap expendable cruise missile versus the expensive sophisticated ballistic missile. Both approaches would continue into the 21st century. For London, the V1 campaign was a terrifying experience that demonstrated both the city's resilience and vulnerability. The same city that had endured the Blitz faced a new kind of warfare and adapted. Civil defence organisations learned to respond to V1 impacts within minutes. Bomb disposal teams developed techniques for dealing with unexploded V1s, incredibly dangerous work as the simple impact fuses were prone to delayed detonation. Medical services coped with the surge in casualties. The human stories from the V1 campaign were often tragic. On June 18th, a V1 hit the Guards' Chapel at Wellington Barracks during Sunday morning service. The chapel was crowded with worshippers. The V1 struck the roof and exploded, collapsing the entire structure. 121 people died, including dozens of military officers and their families. It was the single deadliest V1 impact of the campaign. On July 3rd, a V1 struck a block of flats in Lewisham, killing 51 people. On August 16th, another V1 hit a busy market in Lewisham, killing 33 shoppers. Each impact was random, indiscriminate, impossible to predict or prevent. You were safe until you weren't. The buzzing could be heard across London on busy days, a constant reminder that death was in the air, heading for someone. Children growing up in London during the V1 campaign developed a different relationship with warfare than their parents who had endured the Blitz. They learned to identify the sound of the pulse jet, to stop whatever they were doing when they heard it, to listen carefully, to relax when it passed overhead or tense when the engine cut out. An entire generation learned that silence could be more terrifying than any sound. After the war, captured German engineers were interviewed about the V1 program. Their assessments were remarkably frank. The V1 was developed too quickly. We focused on getting something operational rather than making it effective. The guidance system was inadequate, the warhead was too small, the accuracy was terrible, but Hitler demanded action, and the V1 was something we could build quickly and launch in large numbers. Robert Lusser, the chief designer, was more philosophical. The V1 proved that unmanned aircraft were practical for military use. The technical problems were solvable. With better guidance systems, more powerful engines, and proper strategic planning, the cruise missile could be a war-winning weapon. We were simply too late in the war and too limited in resources to make it work properly. Allied intelligence officers examining captured V1 components after the war were impressed by the simplicity and cleverness of the design. An American report noted, "The V1 represents an entirely different approach to weapons development. Instead of pursuing maximum performance and reliability, the Germans accepted minimal performance and high failure rates in exchange for rapid production and low cost. This was a rational choice given their strategic situation. They could not compete with Allied industrial capacity in producing sophisticated weapons, so they built simple weapons in large numbers. The V1 launch sites in France, captured intact in many cases, provided intelligence about German manufacturing and operational methods. The sites were surprisingly crude, simple steel ramps and concrete bunkers built with minimal resources. Yet they had been effective enough to threaten London for 3 months. The British were sobered by the realization that relatively simple weapons, deployed in sufficient numbers, could create strategic effects even against sophisticated defences. Perhaps the most significant impact of the V1 campaign was on post-war military thinking. Both the United States and Soviet Union studied the V1 extensively. Captured flying bombs were shipped to America for testing. German engineers who worked on the program were recruited by both sides. The lessons learned would inform cruise missile development for decades. The V1 demonstrated that precision guidance was not necessary for strategic effect if you had enough weapons and your target was large enough. London was big enough that even a weapon with 10-mile accuracy would hit something. Modern cruise missiles with GPS guidance and accuracy measured in meters are solving a different problem, but the fundamental concept originated with the V1. In London today, there are memorials to the V1 victims. Plaques mark where flying bombs struck, killing dozens. The Guards Chapel has been rebuilt with a memorial to those killed in the 1944 attack. In the Imperial War Museum, a V1 hangs from the ceiling, its stubby wings and distinctive pulse jet visible to visitors who never heard the terrifying buzz. Veterans who experienced the V1 campaign, now in their 80s and 90s, still remember the sound. In interviews conducted over the decades, they consistently describe the psychological impact as worse than conventional bombing. You could see bombers, you understood they had a crews making decisions. The V1 was just a machine, mindless, indifferent, killing whoever happened to be beneath it when the fuel ran out. There was something deeply unsettling about being attacked by a robot. The final V1 launched at England was fired from a ground site in the Netherlands on March 29, 1945. It crashed in Kent, causing no casualties. In total, the Germans launched approximately 10,500 V1s at England between June 1944 and March 1945. About 2,400 reached London, killing roughly 6,000 people and injuring 18,000 more. The campaign's failure to achieve its objectives was complete. Britain did not surrender. London did not burn. The Allied advance continued. The resources devoted to V1 production, hundreds of millions of Reichsmarks, thousands of tons of strategic materials, could have been used to build fighters and anti-aircraft guns that might have slowed the Allied bombing campaign. Instead, they were expended on a weapon that created terror, but not victory. Yet Hitler remained convinced that wonder weapons would win the war. Even in April 1945, with Soviet troops approaching Berlin, he spoke of secret weapons that would turn the tide. The V1 and V2 campaigns had consumed enormous resources for minimal strategic effect, but they represented Hitler's desperate hope that technology could replace the armies Germany no longer had. The V1 flying bomb was a weapon of terror that arrived too late, worked too poorly, and cost too much to have any real impact on the war's outcome. But it represented the future of warfare. Unmanned, weapons guided by electronics, cheap enough to produce in thousands, expendable and remorseless. The buzz bomb was the ancestor of every cruise missile fired in anger since 1945. In that sense, the sound that terrorized London in the summer of 1944 echoes still in every conflict where precision-guided munitions strike their targets. When that first V1 crossed the English coast at 4:18 a.m. on June 13, 1944, it announced the arrival of robot warfare, the age of the pilot making decisions, exercising judgment, showing mercy or choosing targets. This age was ending. The future belonged to machines that followed their programming without question, without conscience, without mercy. The buzz bomb killed indiscriminately, crashed wherever its fuel ran out, and cared nothing for its targets. London survived the V1 campaign through resilience, technological innovation, and sheer determination. The integrated air defense system that evolved to counter the flying bombs was the most sophisticated in the world, combining radar, fighters, artillery, and balloons in a coordinated network. The destruction rate climbed from 5% to nearly 80% over 3 months, demonstrating that even novel threats could be countered with ingenuity and resources. But the psychological scars lasted longer than the physical damage. A generation of Londoners learned to fear silence more than sound. They learned that death could come from the sky without warning, delivered by a mindless machine. They learned that modern warfare had moved beyond human scale, that individuals were now potential victims of automated systems that killed not from malice, but from pure mechanical indifference. The V1 campaign killed fewer people than a single night of the Blitz. It destroyed fewer buildings than the sustained bombing of 1940 and 1941. But it represented something new and deeply unsettling. The enemy was no longer soldiers following orders, but machines following programs. There was no one to hate, no pilot to curse, just the buzzing of the pulse jet growing louder, then cutting out, and in that moment of silence, the realization that somewhere beneath that stopped engine, death was falling. The effectiveness of Britain's defensive measures against the V1 created a strategic problem for Germany that had no good solution. Each improvement in British defences required German countermeasures, which in turn sparked new British responses. This action-reaction cycle consumed resources on both sides, but Germany was far less able to afford the expenditure. By late August 1944, the British were destroying nearly 4 out of every 5 V1s launched, a rate that made the entire campaign economically absurd. The German response was to increase production and launch rates, hoping to saturate British defences through sheer numbers. At peak capacity, German factories were producing over 500 V1s per month. Launch rates climbed to over 300 per day in August 1944. But this only accelerated the resource drain. Each V1 required fuel, explosives, steel, and labour that could have been used for conventional weapons. The opportunity cost was staggering. Colonel Kenneth Post, commanding anti-aircraft defences in the Thames estuary, calculated that Britain was spending approximately £1,000 sterling to destroy each V1 that crossed the coast, accounting for ammunition, radar operation, fighter fuel, and personnel costs. Germany was spending about 5,000 Reichsmarks to build and launch each V1, roughly equivalent to £500 sterling at wartime exchange rates. Even with the 4-to-1 destruction ratio, Britain was spending twice as much to defend as Germany was spending to attack. But Britain could afford it. Germany could not. The mathematics of attrition warfare were brutally simple. Britain had access to American industrial production, virtually unlimited resources, and growing defensive capability. Germany was being strangled by the Allied blockade, losing territory daily, and seeing its industrial base systematically destroyed by strategic bombing. Every resource devoted to V1 production was a resource not available for tanks, aircraft, or artillery desperately needed on multiple fronts. Some German military leaders recognized this. General der Jagdflieger Adolf Galland argued vehemently that the resources devoted to V-weapons should be redirected to fighter production. In a heated meeting with Hitler in June 1944, Galland pointed out that 10,000 V1s had killed fewer people than a single major RAF bombing raid on Hamburg. The V1 campaign was creating civilian casualties, but had no military effect on British war-making capacity. Meanwhile, Germany desperately needed fighters to defend against Allied bombers that were destroying German cities and industrial capacity. Hitler's response was characteristic. He raged that the V-weapons would break British morale, that terror was a weapon as powerful as military force, that the psychological impact would force Britain to negotiate. Galland left the meeting knowing that rational strategic calculation had been replaced by wishful thinking and desperation. The V1 campaign would continue regardless of its effectiveness, because Hitler needed to believe it would work. The human cost of German desperation was measured in slave labour casualties. The Mittelwerk facility where V1 components were manufactured used concentration camp prisoners as workers. Conditions were appalling even by the horrific standards of Nazi slave labour. Prisoners worked 12-hour shifts in unheated tunnels, fed starvation rations, beaten regularly, and executed for minor infractions. An estimated 20,000 prisoners died building V-weapons, more than the V1 and V2 campaigns combined killed in Britain. The moral calculus was obscene. Germany murdered 4 prisoners for every British civilian killed by the weapons those prisoners built. The V1 campaign, intended as retaliation for Allied bombing, killed more Germans through slave labour than it killed British through explosive effect. This arithmetic of atrocity was entirely deliberate. The Nazi leadership cared nothing for the lives of those they considered subhuman. The prisoners were expendable tools, literally worked to death to produce weapons of limited military value. Allied intelligence was aware of conditions in the underground factories from escaped prisoners and resistance reports. The knowledge that prisoners were dying to build the flying bombs added another dimension to the British defensive effort. Every V1 destroyed represented not just a prevented casualty in London, but a reminder that stopping these weapons meant denying the Nazis any return on their investment in human suffering. The technical evolution of the V1 continued even as the strategic situation deteriorated. German engineers developed a longer-range variant with increased fuel capacity, extending range to 250 miles. This allowed V1s to be launched from sites in the Netherlands, beyond the reach of Allied ground forces advancing through France. From September 1944 through March 1945, over 400 V1s were launched from Dutch sites, primarily targeting Antwerp and other Belgian ports that were crucial for Allied logistics. The Dutch launch campaign was even less effective than the French campaign had been. British defences were now highly refined, with gun crews experienced at V1 interception and proximity fuses making every shell far more lethal. The destruction rate exceeded 85%. More significantly, the V1s launched from the Netherlands had to fly over a longer distance, giving British defences more opportunities for interception. Few reached their targets. Antwerp suffered hundreds of V1 impacts from September 1944 through March 1945, killing over 2,900 people, more civilians than were killed in any other single location except London. The port was a strategic target, the main logistics hub supplying Allied armies driving toward Germany. But the V1s, with their poor accuracy, were as likely to hit residential areas as port facilities. The campaign created casualties and disruption, but did not significantly affect port operations. The air-launched V1 campaign continued sporadically through early 1945. Heinkel 111 bombers would take off from bases in Germany, fly north over the Baltic or North Sea, turn west toward England, and release their V1s from maximum range. These missions had become almost suicidal. RAF night fighters patrolled known approach routes, vectored by ground radar to intercept the slow, vulnerable Heinkels. Crews who flew multiple V1 missions were either extraordinarily skilled or extraordinarily lucky. Most were neither, and casualties were severe. Lieutenant Heinrich Schmidt, a Heinkel pilot who survived 12 V1 launch missions before being shot down and captured in January 1945, described the experience in post-war interrogation. Every mission was terror from start to finish. You flew for hours knowing that British night fighters were hunting you. The V1 under the fuselage made the aircraft unstable and slow. After release, you had to fly straight and level for 30 seconds while the V1's engine started, making you a perfect target. Half the crews I knew were shot down. We joked that the V1 killed more German aircrew than British civilians. By February 1945, the air-launched campaign had essentially ceased. Fuel shortages, aircraft losses, and the manifest futility of the effort led to cancellation. The last air-launched V1 mission occurred on March 14, 1945. The weapon that was supposed to bring Britain to its knees had become a minor nuisance, a reminder that Germany was still fighting but no longer capable of meaningful offensive action. The final chapter of the V1 story involved captured weapons being studied by Allied engineers and intelligence services. Intact V1s were recovered from crashes, carefully examined, photographed, and tested. American and British engineers were impressed by some aspects of the design and dismissive of others. The pulse jet was clever but inefficient. The autopilot was simple but too crude for military applications requiring precision. The airframe was cheap but structurally weak. What impressed Allied engineers most was the manufacturing philosophy. The V1 had been designed from the outset for mass production, using semi-skilled labour and non-strategic materials. Every component was standardised, interchangeable and simple to assemble. This was industrial design at its most ruthless, stripping away everything unnecessary to create a weapon that could be built quickly and cheaply. In an economy of abundance, you built sophisticated weapons with tight tolerances and complex systems. In an economy of scarcity, you built crude weapons that barely worked and produced them by the thousands. The United States Army Air Force conducted extensive testing of captured V-1s at Wright Field in Ohio. Test launches from reconstructed German catapults demonstrated the weapon's capabilities and limitations. American engineers concluded that the V-1 could be improved significantly with better guidance systems, more powerful engines, and refined aerodynamics. These studies influenced American cruise missile development in the late 1940s and 1950s. The V-1's basic concept was sound, the execution had been limited by German technological and resource constraints. The Soviet Union also studied captured V-1s extensively. Soviet forces overrunning German V-weapon facilities in 1945 seized documentation, components, and technical personnel. Stalin was fascinated by unmanned weapons, seeing them as ideal for a military force that had suffered staggering casualties and might face manpower shortages in future conflicts. Soviet engineers developed their own versions of the V-1, improving the guidance systems and pulse jet design. These weapons never saw combat use, but the technical lessons influenced Soviet cruise missile programs for decades. The psychological legacy of the V-1 campaign extended far beyond the immediate wartime experience. Children who had grown up listening for the buzz bombs developed lifelong anxiety responses to certain sounds. Veterans described hearing phantom buzzing decades after the war, their minds still trained to identify the threat. The distinctive sound of the pulse jet had imprinted itself so deeply that even hearing similar mechanical noises could trigger fear responses. Dorothy Harrison, who was 12 years old during the V-1 campaign, recalled in a 1994 interview marking the 50th anniversary, "I still can't hear certain sounds without tensing up. Small aircraft, motorcycles, even loud ventilation systems sometimes trigger the old fear. Your brain learned that the buzzing meant danger, and even 50 years later that association doesn't entirely go away." I remember standing in our garden, frozen, listening to a V-1 pass overhead. The engine cut out when it was almost past us. In that silence, my mother grabbed me and we ran for the shelter. We heard the explosion maybe 10 seconds later, felt the ground shake. It had crashed 3 streets away. 6 people died. That could have been us if the fuel had lasted 3 more seconds. You don't forget that randomness. The medical community studied what they called V-1 neurosis, a specific pattern of anxiety symptoms related to flying bomb attacks. Sufferers experienced hypervigilance, startle responses to loud noises, difficulty sleeping, and intrusive memories of V-1 impacts. The symptoms resembled shell shock from World War I, but with unique characteristics related to the specific nature of the V-1 threat. The unpredictability and lack of human agency made it particularly difficult to process psychologically. Dr. William Sargant, a psychiatrist who treated civilian casualties during the Blitz and V-1 campaign, noted significant differences in psychological responses. Conventional bombing raids created acute terror, followed by relief when the raid ended. The all-clear siren marked a definite end to danger. The V-1 campaign created chronic anxiety without clear boundaries. The weapons could arrive at any time, day or night, without warning sirens. There was no all-clear. The danger was constant and ambient, which created different and more persistent psychological effects. The physical reconstruction of V-1 damage took years. Some areas of London bore scars well into the 1950s, with bomb sites remaining as empty lots or temporary parking areas. The priority was housing construction, not repair of all V-1 damage. Some structures damaged by flying bombs were simply demolished rather than repaired, changing the urban landscape permanently. Walk through London today, and you can still see evidence of wartime destruction. Buildings from the 1950s standing next to Victorian structures, marking where V-1s or conventional bombs destroyed what had stood before. The diplomatic aftermath of the V-1 campaign influenced post-war agreements on weapons development. The indiscriminate nature of V-weapons, their deliberate targeting of civilian populations, and the slave labour used in their manufacture were all cited in war crimes prosecutions. At Nuremberg, the V-weapon program was referenced as evidence of Nazi disregard for international law and human rights. Several engineers and administrators associated with V-weapon production faced trial. though most technical personnel were recruited by Allied powers rather than prosecuted. The legal and ethical questions raised by the V-1 have never been fully resolved. Was an unmanned weapon targeting civilians worse than manned bombers doing the same thing? The Allied strategic bombing campaign killed far more German civilians than V-weapons killed British civilians. The moral distinction, if any, lay not in the effects, but in the intent and the automation. The V-1 was designed specifically to terrorize civilian populations through random, unmanned attacks. Conventional bombing, however destructive, involved human decisions at multiple levels. These distinctions seemed important at the time, but look increasingly tenuous in hindsight. Modern military ethicists studying autonomous weapon systems reference the V-1 as a historical precedent. It was the first weapon that killed entirely without human intervention once launched. The autopilot determined when to dive, the target was selected only in the broadest sense, and individual victims were chosen by pure chance. This removed human judgment from the killing process in a way that felt morally troubling, even in the context of total war. Contemporary debates about drone warfare, autonomous weapons, and AI-guided systems echo arguments first raised in response to the V-1. The technical descendants of the V-1 are everywhere in modern arsenals. American Tomahawk cruise missiles capable of hitting targets 1,500 miles away, with accuracy measured in meters, represent what the V-1 could have become with 7 decades of technological development. Russian Caliber missiles, Chinese YJ-117s, and dozens of other cruise missile systems all trace their conceptual lineage to the flying bomb that terrorized London. The basic concept, an unmanned aircraft carrying explosives to a distant target, remains unchanged. Only the guidance, propulsion, and accuracy have improved. The pulse jet engine, dismissed as crude and inefficient, has had an unexpected afterlife. While no military applications continued after 1945, pulse jets found use in experimental aircraft, target drones, and even hobbyist projects. The simplicity that made them attractive to German engineers in 1942 makes them interesting to experimenters today. You can build a pulse jet in a home workshop with basic tools and materials. Enthusiasts have powered go-karts, bicycles, and small aircraft with pulse jets, drawn by the distinctive sound and mechanical simplicity. The launch catapult system developed for the V-1 influenced post-war aircraft carrier technology. The steam catapult used to launch modern carrier aircraft operates on principles similar to the Walter HWK-109 system, using superheated steam to accelerate aircraft to flying speed in a short distance. British and American engineers who studied captured V-1 launch ramps recognized the potential for adapted versions to launch conventional aircraft from carriers. The first operational steam catapult was installed on HMS Perseus in 1950, directly descended from German V-1 technology. The guidance systems, primitive as they were, demonstrated that autonomous navigation was possible for military applications. Post-war cruise missile development focused on improving guidance accuracy, but the basic components of the V-1 autopilot, gyroscope for stability, compass for heading, and preset distance counter, remained fundamental to guidance systems until GPS and inertial navigation became practical in the 1970s. Even modern cruise missiles use conceptually similar systems, just implemented with digital electronics instead of mechanical linkages. The V-1 campaign's failure to achieve strategic objectives provided important lessons for post-war military planning. Precision matters more than volume for most military applications. Accuracy allows smaller warheads to achieve effects that require much larger weapons if targeting is imprecise. A single bomb on target accomplishes more than 1,000 bombs scattered randomly. This seems obvious now but was not clear in 1944. The V-1 demonstrated the limits of quantity without quality. Conversely, the V-1 showed that even relatively crude weapons could create significant effects against soft civilian targets. The campaign disrupted British civil defence, industrial production, and daily life for months. It diverted substantial resources to defensive measures, tying up fighters, guns, and personnel that might have been used elsewhere. For a weapon that rarely hit its intended target and killed relatively few people, the V-1 had an outsized impact. This suggested that terror weapons, while militarily ineffective, could still serve strategic purposes by creating fear and consuming enemy resources. The economic analysis of the V-1 campaign conducted after the war revealed the full extent of its futility. Germany spent approximately 500 million Reichsmarks on V1 production, launch facilities, and operations. Britain spent roughly £150 million on defensive measures, equivalent to about 1.5 billion Reichsmarks. The damage inflicted on Britain was valued at approximately £50 million. So Germany spent the equivalent of 500 million Reichsmarks to inflict damage worth about 500 million Reichsmarks, while forcing Britain to spend 3 times that amount on defence. From a purely economic standpoint, Britain could afford those expenditures while maintaining full war production. Germany could not. The resource allocation question haunted post-war analysis. What if those 15,000 V1s worth of material and labour had been devoted to fighter aircraft production? Germany could have built approximately 10,000 additional fighters with the same resources. Those fighters, properly employed, might have inflicted significant casualties on Allied bomber streams and delayed the destruction of German industrial capacity. Or the resources could have produced tanks, artillery, ammunition, all weapons with proven battlefield effectiveness. Instead, they produced flying bombs that killed a few thousand civilians and had no impact on the war's outcome. Hitler's strategic vision, such as it was, rested on the belief that terror would break British morale and force a negotiated peace. This was a fundamental misreading of British character and political reality. The Blitz had not broken British morale. The V1 campaign, arriving when Allied victory was clearly inevitable, had even less chance of creating political pressure for peace. By June 1944, Allied forces were advancing on all fronts. German cities were being systematically destroyed, and defeat was a matter of time. No amount of flying bombs falling on London would change those realities. The psychological projection was telling. Hitler assumed British civilians would react as he imagined German civilians reacting, that sustained terror bombing would create pressure on the government to surrender. This revealed more about Nazi thinking than British psychology. The Nazi regime rested on fear and intimidation, so Hitler assumed those tools would work against enemies. He failed to understand that democratic societies with political legitimacy could endure hardships that would topple authoritarian regimes. The British government's handling of the V1 threat demonstrated effective crisis management. Initial censorship prevented panic while allowing civil defence to prepare responses. Gradual release of information helped the public understand and cope with the threat. The visible defensive measures, fighters, guns, balloons, reassured civilians that action was being taken. Churchill's direct acknowledgement of the threat and progress in defending against it maintained morale. By treating citizens as adults capable of handling difficult truths, the government maintained public support even as flying bombs fell daily. The contrast with German handling of V-weapons was stark. The Nazi propaganda machine promoted the V1 and V2 as wonder weapons that would win the war, creating unrealistic expectations. When the weapons failed to produce decisive results, German morale suffered another blow. The overpromotion of untested weapons as war-winning superweapons was characteristic of Nazi strategic communication, promising miracles while reality delivered incremental improvements at best. The final accounting of the V1 campaign produced statistics that seem modest, given the effort expended. Of approximately 10,500 V1s launched at England, about 7,500 crossed the coast, roughly 3,500 were destroyed by defences, and about 2,400 reached the Greater London area. Those 2,400 flying bombs killed approximately 684 people, seriously injured 7981, and destroyed or damaged over 30,000 buildings. An additional 2,300 V1s were launched at Antwerp and other continental targets, causing over 2,900 deaths. Compare those numbers to a single conventional bombing raid. The RAF attack on Hamburg in July 1943 killed over 40,000 people in 1 week. The USF and RAF attacks on Dresden in February 1945 killed between 25,000 and 35,000 people in 2 days. A single manned bomber raid could produce casualties exceeding the entire V1 campaign. The V1 was inefficient even as a terror weapon. Yet the V1 achieved something no conventional bomber could. It made death random and impersonal in a new way. When bombers attacked, you knew humans were making decisions about targets. The V1 killed without intention, without awareness, without any possibility of mercy or mistake. This quality of mechanical indifference was genuinely new in warfare and genuinely disturbing. It suggested a future where humans would be casualties of systems rather than conflicts. killed by machines following programs rather than soldiers following orders. That future arrived gradually over subsequent decades. Modern warfare increasingly features unmanned systems, precision weapons guided by algorithms, and violence delivered from great distances by operators who never see their targets. The V1 was primitive compared to contemporary weapons, but it established the template. Warfare could be automated, delegated to machines, conducted remotely. The human element could be removed from everything except the decision to launch. The ethical implications continue to generate debate. Is a weapon less moral because it lacks a human operator? Is precision guidance that reliably hits intended targets better or worse than area weapons that kill randomly? The V1 landed randomly, killing whoever happened to be beneath it. Modern precision weapons kill deliberately, striking specific targets but potentially with greater certainty and less warning. Which is worse, death by random chance or death by algorithm? The questions raised by the buzz bomb remain unanswered. For the survivors of the V1 campaign, these philosophical questions were secondary to lived experience. They endured 3 months of random terror, learning to live with constant threat, developing coping mechanisms that would last lifetimes. Some became fatalistic, figuring that worrying changed nothing. Others developed elaborate rituals and superstitions. Many simply carried on, adapting to the new abnormal with characteristic British stoicism. The sound remained the defining memory. Decades after the war, survivors would describe the buzz in detail, the specific pitch and rhythm of the pulse jet, the way it changed as the V1 approached and passed overhead, and especially the sudden silence when the engine cut out. That silence appears in every account, every interview, every memoir. The moment when buzzing stopped and you waited to hear where the explosion would come, knowing that someone somewhere was about to die, and hoping desperately it wouldn't be you or anyone you loved. The V1 flying bomb was Hitler's first vengeance weapon, primitive, crude, and ultimately ineffective. It killed thousands but changed nothing strategically. It consumed resources Germany couldn't spare to produce effects Germany didn't need. It represented Nazi desperation and delusion, the belief that wonder weapons and terror could substitute for armies and rational strategy. The buzz bomb was a footnote to the war's outcome but a preview of warfare's future, where humans would increasingly delegate violence to machines and live under the threat of automated death. That future has arrived, and it sounds like buzzing.